How many types of UDF? Anybody remember? Yeah, three types of categories of UDF are there, right? UDF, UDAF, and UDTF, right? So what is the difference between the UDF and UDAF and UDTF? Can anyone tell? Yeah, please speak out, right? I'm asking the same thing what I taught, right? I'm not asking different thing, right?
Uh, UDF takes one input and returns one output value,
Okay.
and coming to UDF, it takes some list of input values instead of one input value.
And return one output value.
Yeah. And UDTF, it takes the input table as an input, and the output will be maybe some collection of items like
Yeah,
array.
table itself is yeah, table is output.
Yeah.
That is UDTF. Okay. So user defined table function like the explode function is there. Okay. Lateral view is there. So that is the UDTF examples. Okay. Where we take input as a table and return output is a table. Okay. And UDF example is sum, average, like main, max, count. Those are aggregate functions. Example comes in the category of in the UDTF, UDAF. Okay, and so can you tell me what is any use case of UDF, right? Where you would like to use the UDF, right? Why we go for UDF? Any use case of the using the UDF? What is the main purpose of UDF is right user defined function, right? Custom function, the functionality which is not there in their inbuilt functions. So we can use the UDF, right? We can write our own custom logic in Java class, and then we can call that function as a temporary function, and then we can use in our queries, right? So that's basically purpose of the UDF. Okay. And what is the difference between the Avro, Parquet, and ORC? What is these are the three file formats. So what's the difference between the Avro, Parquet, and ORC?
Row is row format, and Parquet and ORC are columnar format.
Okay, okay. And what else?
Avro is good for write operation, and other two are for read operation.
One more difference is there that is very important one, the schema evaluation, right? So Avro is fully supporting schema evaluation support, right? We can write the, right? We can add or remove any column from anywhere in the scheme. Okay, but ORC Parquet is supporting partially. If you are removing or adding any column, it will be at the end of the scheme. So it's not fully supported, okay, in ORC Parquet. But ORC Parquet is giving more higher compression as compared to Avro. So highest level of compression is there in ORC. Okay, and second number is RK, and then lowest one is Apple. So these are the three main differences. And Parquet is using snappy compression. That is a default compression technique. So there are the three, four different types of compressions. There is snappy, Lazaro, G, BG. Okay. So snappy is a compression technique used by Parquet. So Parquet and ORC both are common file format, but ORC is having more higher compression than Parquet. Okay, so so first example is the export function. Let's see that how export function will be converting list of arrays value into the different rows. So if I have example, let's take an example like I have a student, okay, and student ID and marks. Okay, marks is array column. So I say one is a student ID, and I have a marks is a student. Three subjects marks are that. Okay, I want I want to make it explode this marks column. So I want like this 134, okay, 156, okay, and 167. So like this output I want. Okay. So because explode is a one limitation, I will tell you that another literal view is there that will solve that problem. So when I apply the explode function, okay, on the marks column, so we cannot use any other column at the same time. We cannot use in the select. Okay. So if I try the select student ID and then explode of marks, it will not allow. So we have to use lateral view. Only if I'm just doing only marks, right? If I want the arrays of values into multiple rows, I will get it. Okay. But along with that, if other columns of the table, right? I want to get the data, I cannot do. So the other alternate way is lateral view. The lateral view is we can solve this problem, right? Where we can have full column with for each row. So let's try with this thing. have like this kind of data. So how to write it? Because this is called fixed width file. So fixed width file is a file where is no delimited character. It's a kind of regex only. You already seen the regex example, right? Where the log files data, right? So it is also fixed width, but here we will use the width, like every column width. Okay. So I will say this is the 6 column. This is again 7, 8 column, right? So like this, I will based on the every column width, right? One fixed width is there. So I will write the data. So just I take an example of some record. I will create this type of data. I have to create a table like so. If I'm saying I have to create a 3 columns, right? First, second, third column, right? I want to create. So I will be defining the size. Okay, and if the number column is there, D is there, right? So I'm just defining the regex. This is the kind of regex I'm defining. And I'm going to create a table, creating table, and then loading the data. So loading data is the same process. We will be using load data, so and then we will get the location of the file. Okay, into you have to do table, into table, table, station step. So once we load the data, okay, so like this we can get the data. Okay, so we can define the data and this fixed width file. So this is also regex. Okay, it is using regex-serde. So regex-serde is the hive provided serde. Basically, we don't need to add any additional jar, right? You know, for JSON-serde we need a jar, XML-serde we need jar, but for regex-serde we don't need any additional jar. So this is present in the library, in hive library. So, so this kind of data is a fixed width file, but we are using here the regex I'm defining with the width. I'm defining the width of the column, and based on the width of column, I'm reading the data and writing to the hive data. Okay, this is clear. So this is the example. The last time I had to follow this example. Okay. This one, so I will do at the time. And XML1, right? Last time we tried. So one way is serde. Another way without serde also we can use. So what is the approach is there? There is a called XPath. Okay. So what is this XPath? Suppose you have a data. So first you will create a table as a string column. Only one single column you are keeping it. Okay. And this table, what you are doing, you load the data, this entire XML data you will load it, right? And after that, you will define your XPath. So XPath is basically you will be selecting the data from same one column, string column, but you are specifying what is the position of your data. So suppose if I say my EMP is my root tag, ename is my like a sub element in my root, and I want to get my text data of value. Okay, that is a RAM. Same thing like if EMP is my root tag and eCell is my salary and this is text. So this thing will repeat it for each of the employees data. So how many employees records are there in this? Two employees record, right? So two rows will come. Okay. So first thing what we need to do, we have to, so XML survey is a one way. So that is the same like XML survey. Okay, so here is some error. I will check that. But this one is the X path. Okay, so here is I am creating a file. I am creating a table. Okay. Dot XML, and then now I will. X path. This is the same table. Now our next is we cannot read like if I do select star from table, what it will do, and what is the difference by this? If I select star from table and the, like a string, it will be because we have loaded entire XML data. We have loaded entire XML data. It's it is like a 8 rows, right? It's a one single column data is entered, not multiple rows. It's a like multiple rows with a single column. Okay, one single column with multiple rows. So when I do this query xpath one, data is written as multiple lines. Basically, we have to write single line. Then it will be applying the text form. So, data in the table. We are using override, so it will existing data, it will be overridden. If I do select star, so I'm getting a one single line data, so one row is coming. Now I apply my X bar. Check this one. Meanwhile, we do okay, export. So when we are trying explode function, so I told like explode is one function. It's udtf, okay, user defined table function. So there are the two things are there, explode and letter B. Okay. So explode has the one limitation that is overcome by the this lateral view. Okay. So here, if we see one example, like I have some array type of data is there, and I want to get the exploded data. Here, just we apply the explode on one array only. So I will write the data, insert data. So here, like one table is there. So this table, I will write the data like as a array data I'm writing. Hive, Hadoop is part. So here is a ID is there, name is there, location is there, and source is the array type. Okay. So I'm using arrays of the string type. Okay. So arrays of the string type, and I will load the data, and after that I will apply the explode function on the code. So then I will get the all the values in the my course. It will be coming in the one single column but multiple rows. But I cannot use the any other column, right? I want to use student ID. So how I come to know this student ID has this particular course, this particular student ID is this particular course. So this is a limitation. Then we went to the, we will be using the lateral view. How to define the lateral view? Okay. So let's first create this table. I will load the data. So this is a manual way I'm writing the data. I'm not using the any file, right? I'm not loading data. Just insert into table format. I'm getting, yeah, so I'm getting the column. This is my array column. So I apply select of what is my column name? Course. Course is the column. So I will be doing, if I try, okay, what is my first column is, one column is std underscore ID. Okay. So we can say std ID explode or course column from TF are not supported outside the select clause nor nested in the expression. Okay. So if I remove this std underscore ID, I keep it only explode to see the result is coming. Okay. So here you found it like explode cannot use any other column, along with explode we cannot use any other column. Okay. Now we will apply the lateral view. Okay. So how to apply the lateral view? Same result is coming. The lateral view explode the array data into multiple rows. In other words, expand the array into rows. But when you use that along with the export function, like we can use the other column. So select std ID, student name, location, courses. From the first we are writing as it is, whatever field I want. And then I will say lateral view, explode course, okay. And courses list, some alias I have to give here because I'm just talking about this. Courses list means list of courses as courses. So I should remember it whenever I give as courses, this or this should be same. Okay. So whatever my column name is here, that should be the same column name here also. It's a course only. Okay, this one we have created manually the column. Actually, this column is not part of the table. So the column, the last column, this column, other columns are table column. Okay, but the last column is particular the array type column. So I have given whatever alias I given here, same alias I have to use here courses. Okay, but how the value are formed? I'm saying here lateral view. So I'm just creating the on the fly view. So dynamic view I'm creating on the table, on the top of the table for this particular course column. Course column. In this particular course column, I'm exploding and getting the courses underscore list. Like the courses is the view column. Okay, and that view column I'm using with this. So how many courses are belonging to the person? It will be exploded. If you see here, so like Bamsi has these 3 courses, Channa has these 2 courses. So now here we are getting the data. Is it clear that how to use lateral view, how to use scope function? Okay. So there are many other use case also there using lateral view export to an array column, map column. So map also we can use with multiple columns. So that is the use case of the lateral view. Okay, so next thing in the hive is left. So we want example of okay, bucketing is pending. Okay, so we have not gone through the bucketing concept. So let's go through the bucketing concept. So what is the bucketing? Because last time we done the partition. So when we talk about the bucketing, right? The bucketing is also one more way of improving the performance tuning technique, but that is on top of the partitioning. So bucketing can be used alone also. Without partitioning, we can use bucketing. So bucketing is nothing but creating a physical output file. Physical output file maybe in the same within a partitions. If you are using partition, so it will be a part of the partition, within partition or without partition. Okay. So if I take an example, like I have 100 records are in my table, okay, in my table, and I'm just doing partition on the city, okay, partition on the city, okay? And this data is employee record data is there. So employee data is there. And when I say city column and I say, suppose I have 10 different cities data, 10 different cities data. And I'm saying like I have a 10 different cities data, this 100 records divided into the 10 records. I'm assuming right for every cities 10 records are there, 10 records in each city. Okay, in each city. So now if I do partitioning, okay, so partitioning I'm doing first, okay, when we create a table. So if I'm doing a partition, so as per partition, my 10 records will be divided into the each partition, right? So I say first partition, first city partition, I have 10 records. And second city partition, I have again 10 records, okay? And I told like bucketing is further, right? In the partition, you have only one single file. You have seen when you are not using bucketing, with this 10 record, the 10 records are in a one partition file, one file. Okay. And that file name, 000 is there. This file is there, right? Okay. But when I say I'm going to use bucketing, so how to define the bucketing in the table? So when you say create table, my table, and then you have a field of the table, okay, fields of the table, and then you say partition by, city, and then clustered by key, you say bucketing, the clustered by key, clustered by, you say key name, right? What is the clustered by here? Employee ID. So partition column, you should always choose the column which is repeated data, but bucketing column should be a column which has unique data, because suppose this 10 records is a one single file when we are using bucketing. So suppose I'm saying clustered by EMP ID into number of bucket into, I say 3 buckets. So every partition divided into the three buckets. Okay, so this 10 records are divided into 3 files. So I told like how many buckets means how many buckets are there, those many number of files are there. So that's the logic here in the bucket. So what is the advantage of keeping the more files? The advantage is like in the one single file, when you are suppose you are doing a query, you are saying I'm doing a one query, select start from my table and say where city equal to some city you said, and you said EMP ID record I want to search. We say EMP ID 4, 3, whatever. So if this EMP ID 3, so in the what it will do first, it will check first the partition column, it will find which partition, and then it will check if it is a one single file, all the record in a single file. So it will be searching from start to end, right? All the 10 record it has to search. But if I divide it into 3 files, just assume it like one is having 3 records, second has 3, and third one is a 4 record. So in this scenario, what will do, it will check because these records are stored as a hash key. Hash key is a way to write the data. Hashing technique is used by bucketing to write the data into bucket, into number of files. So it knows that this for this 3, what is the hash key, and it will find out out of these 3 files, where is this particular employee ID 3 record. Suppose I found in the second bucket, right? Like this is the first bucket, this is the first, this is second bucket, and third bucket has the 4 record. So I found it like it is finding the data more quickly. So if I'm not going to use bucketing, right, for the large files, it is very useful, because for small files, like small tables where the data is less, and the partition will help you improvement of the performance, but it is a limitation, right? Like if you have divided data into partitions, but further you want to in your query, right, you want to get the data in a unique ID. So how can you get it, right? So in this scenario, like you will be doing a less scanning of the data, right? Because earlier you were be doing only this query, where city equal to XYZ. So only all records for the same partition you want. So you have given all 10 records, but now I have to return only one record. I have to return only one record, and this one record is in out of the 3 files, right? So first thing comes like how to implement the bucketing, right? So I told bucketing can be used alone also. Suppose I'm not using the partition in my column, partition not using the table. So without partition also I can use clustered by key. So I can use like this clustered by EMP ID. So even my data is there, whether the partition is there or not, but still my data is there in the file. So this primary key column will be there, right? This EMP ID, like I'm saying, the unique ID value, right? The ID is not repeated. So that particular column I'm choosing for the clustered by key as my bucketing column. And when I'm saying a question comes, how to decide this thing, right? The number of bucket, how to decide. So suppose your data is there. Suppose you say you have 2300 MB data. So 2300 MB data like is pointing out to some number of records. Suppose I say it's 100,000 record. I'm saying 23 MB data size is there, 100,000 record. Okay. And 100,000 record also number of columns also matters, right? Because maybe 100,000 records are there, but column is only one. So data will be less size. If 100,000 record is there, but number of columns are 100 columns, so automatically data size will increase. Okay. So how can I find the data size of the table? Simply I can check on the Hadoop file system. I can check the directory location because every table in Hive is pointing to the some directory location. You know, right? In the warehouse, we have database.db folder and then table folder. So every table in Hive on HDFS has a directory, table directory location. So you know Hadoop command to check the size of the table. So we can check Hadoop command to check size. df -h command we can use to get the size of the table. Okay, file. Okay, whatever file is there inside that directory. So once I come to know, so here what is the way to find out how many good number of bucket we should take it, because it's not like exact number, right? But we can calculate it. Okay, how this calculation is done. So suppose whatever your data size is there, like 2300 MB. Okay, and what is your block size? So we already know block size, right? We all aware, right? Block size is the 128 MB in Hadoop 2.x and 3.x. Okay, so if I say one block size is 128 MB, so how many blocks will come in this 128? So if I divide it, 2300 MB, I'm getting 17.96. So 17.96. So 17.96, I got the calculation 17.96. So I need to check this 17.96 2 to the power 5 is greater than. So if I check 2 to the power 4 I do, so 2 to the power 4, 2 to the power 4 is basically 16, and that is not greater than 17. That is not 16 is not greater than 16 is not greater than this one. Okay, so I cannot choose the 16 is my number of bucket. So next one is number 2 to the power 5. So when I do this, so I will find the number 32, right? So this 32 is greater than, this is correct, right? Is greater than is 17.96. Okay. So my number of bucket for a table, for this much of size table I'm talking about. So if I say this number is a 17.9, say, okay, this is just little less, less, right? This 16 is little less. So if I say if my size is a 20, like a 2 GB size, this is a 2.3 GB, right? 2300 MB is a 2.3 GB. If I say 2000 MB, suppose my table size is there, 2000 MB. Okay, so 2000 MB will be if my blocks same block size. So then I will say my 2 to the power 4 will be like is greater than, right? The number which will be divided by 128. So if I do 2000 15.62. So this 15.62, so 16 to the power 5 is greater than, that is the to the power 4, to the power 4, that is 16, and which is greater than 15.62. So here little less size is reducing the number of buckets. Now the 16 bucket and here is the 32 bucket. Just because of the 300 MB data less, so how it will be affecting. Okay, so this is the calculation, okay, that we can understand, okay, how to decide the bucket. But bucketing can be used, which is greater than 15.62. So my number of buckets will be here in this scenario 16. Okay, and here the number of buckets will be with the 2300 MB data, the number of bucket is 32. Okay, so now the question comes like how to enable the bucketing. Bucketing is not by default enabled. Okay, so we have to, like, you remember, right, dynamic partition we have to enable. There is a dynamic partition true property is there. Okay, similar way we enable the bucketing. Okay, so bucketing can be enabled. Bucketing can be enabled, like enforce bucketing property is there. Okay, enforce the complete property I will tell you. Enforce start bucketing, that's true. Okay, so if your bucketing is so this property, if I set it, then bucketing will be allowed. So first thing is we have to create a table. Okay, we have to create a bucketed table because we have to define the clustered by key. And the thumb rule for the clustered by key is the ID, which is a unique key column, like value is unique values. Okay, and generally like order ID, employee ID, right? So this kind of columns we choose for the clustered by key. If partition column we want to choose, we use the city column, date column, country column, state column, where the repeated data is there. Okay. So once your bucketing is allowed, then you will see, so far you are able to see whenever your you will be seeing like the city equal to like XYZ city partition, right? And further, you will see after that, inside this one, there was only one file was there. Okay. But now you will see different files will be there, right? So suppose one file is a 000, another file is 0001. So like this, it will create a file depending on the number of buckets is given. So number of buckets are basically it's equal number of records will be divided. Okay, so that way it will be creating the it will be writing data. So only bucketing is basically providing the faster way to retrieval of the data. That is the benefit of using the bucketing. So generally we prefer when we have partition in the table, and on top of that partition column, inside that we create, inside that we go for number of output files. So when we say what is bucketing definition, so bucketing is nothing but creating a physical output file within partition to improve the performance of partition further, to enhance more performance, right? We can improve. Okay. So generally partition we use, like we know, right? It's a set of data, logical group of the data, and whenever you are querying the table, you can get the data from the partition directly, right? So within partition, when you are set this, so hashing technique is used, right? Hashing technique is used to distribute number of records within partition into number of output files. And when the query is given, right? So then it will be searching based on hash key. So whatever hash key is used to write the record in a file, based on the hash key, the record is written. The record is written in a bucket and saying at the time of retrieval, it will be fine. So that is basically strategy used in the bucketing. Okay. Okay, so one example of bucketing I'll show you, create table, like how to create the bucketing example. Table, create table if not exists, right? This is New York taxi, some sample data, right? This is like a trip IDs are there, right? So vendor and pickup date time, right? So this is very well known data set. So New York taxi. Okay. So suppose just understand like we can create our own data. So here if you see here the one table, this is called bucketed table. Why bucketed table? Because here we are using cluster, but here we are not using partition, right? This is without partition. Just I'm doing clustered by trip ID into 20 buckets stored as parquet. Okay. So this is the location I'm giving for my file, but here I'm using the S3 location because this is the table is created in the hive in AWS. So there I'm using some EMR cluster. There I'm using this hive. Okay, I'm not using in my like Ubuntu or some other like Cloudera. Okay, so if I giving my local like a Hadoop location, so I will give Hadoop location. So next thing is how to populate the bucketing table, right? So we have to write the data into bucketing table. So it's not so we have to use bucketing. I was saying some hash function to go into the record. So this is the modulo operator. You know, right? There is we were checking in the map reduce, right? Partition, right? We use, right? We our own custom partitioner class that was also using hash partitioner. So this hash partitioner is the same as here, like percentage modulo. Okay. So reminder, it will get the reminder. Okay. So first we have the table. We will load the data into table. So this is the source table I'm creating. Okay. Because from this table, I will load the data into my bucketed table. Then I have set the property enforce bucketing property. I told like I have to enable bucketing. Then I created another new table and I'm saying clustered by ID into P bucket. Okay, only this new clause I have to add. Here I'm not using partition. Just I'm trying to show here bucketing, right? My instead of data will be going as a single file, it will be going multiple files, like multiple files in the directory location of my Hadoop file system. Okay. Then when I write the data from source table to my bucketed table, so I will see after that, I will go to my table location. So I should see the three files, 0000 file, 0001 file, and 20 file. This is the three equal size of the files are created. So how many records will be there? It will be divided into the three files. So when I'm doing query, so see, I don't need to worry about inquiry like from where the data is coming. So I'm just giving my, okay, so if I say this is the logic, right, which bucket the data will go. So depending on the hash function, so ID value is 6. So 6% is 3, 3% is 3. So it will go to the 0 bucket. If the ID value is 7, so and ID value is a 4 and ID value is a 1, so it is all going in the 1 bucket. If ID value is other record, right? Suppose ID value is, I say, 8 and 5 and 2. So automatically your data is distributed based on the hashing, like based on the hash value, it will be distributed into the particular bucket. So you will see when you do cat, you will get the data is stored. But now next thing is when you do query, now you say select star from table and then particular this ID column you say like 8, where ID equal to 8. So what it will do, it will go to only that bucket. It will not check the other bucket because it knows like what hash value is here, what hash value is here, what hash value is there. Okay. So according to hash value, it will again calculate the hash value while retrieving data. While writing data, it is checking hash value and writing the data into file in output file. And while reading data also, it will check. Okay, they have not given the select query, but it will be faster because here it's using completely hashing, and hashing is giving a benefit of like distributing your record into number of output files. Okay. Try this example, you will easily understand. And same example we can do with partitioning also. So whatever your table is there, partition table, just use same partition table, but you give extra one class clustered by, you add one clustered by. So everything will remain same as partition only, but whenever you see the partition folder, you will see there is multiple files are created in each partition. So here is only one single directory location where all the data is in a one single file is divided into the three files. All the data is divided into the three files, but their partitions are divided into the number of files. Okay, because when you are applying the partition by and then cluster by, so clustering is applied on the partition level, but here is the clustering is on the table level, like the entire table data into three output files. But in the clustered by you are using after partition by, then your clustering, like your bucketing will be applied on the partition link. Okay, so you will see your data will be within partition, you will see your data files will change from 1 to 3. Okay, so logic is same whether you use either partition by, clustered by, or you use only clustered by, but you have to enable this property. Okay, okay, so try this one. Anything is there, let me know. Okay, I will see that. Okay, so I will share you this document and this fixed width file. Okay, so I will sort it out, that issue in the fixed width, like one issue is two, and then I'll ping you from. Yeah, thanks everyone. Thank you. So tomorrow I will be starting the scoop. So you can go through a little bit background of the scoop, right? What is the scoop, import tool, import export. Okay, thanks everyone.